All right, so in competitive and non-competitive, right, as the name suggests, one inhibitor is competing with the active site. That means it has the same shape as the active site, or the complementary shape for the active site. And the substrate would have the same shape, so they are competing for the active site. That is why it is competitive. Because both of them are competing, if you increase the amount of substrate, then there's a greater chance that it is the substrate that will bind and not the inhibitor. So increasing the substrate concentration will help. And also the enzyme structure, it is not affected. Now in allosteric or non-competitive inhibition, the inhibitor is not going to bind to the active site. It is going to bind somewhere else on the enzyme. However, when it does that, it changes the shape of the active site. So what is the purpose of the inhibitor? No, we don't want the inhibitor. No. The inhibitor is going to slow down the inhibitor is going to slow down the rate of reaction. So like the cyanide poisoning, it's a respiratory inhibitor. Go ahead, Cameron.
Sir, for the allosteric inhibition, you have competing with the enzyme for the active site. Should it be the substrate?
Wait, for allosteric?
Yeah.
Which part?
In black at the top.
Black? It is non-competitive because the inhibitor is not competing. Yes, thank you. Substrate. Answer that right. It is not competing with the substrate. Remember now, the purpose of enzymes is to catalyze reaction. They work on substrate. So you don't want inhibitors interfering with that process. Unless it's a reaction you would not want an enzyme to carry out. All right, so I was saying about cyanide poisoning. It's a respiratory inhibitor. It prevents the process of cellular respiration. All right, so you don't want that to happen. Right. So just remember, in allosteric, it is binding elsewhere on the enzyme, and it is going to change the active site. When you change the active site, the substrate is not going to bind to it. So because the substrate is not binding to your enzyme, it doesn't matter if you increase it because it is not binding to it in ways. Increasing the amount of substrate, it will not help. All right, it will not increase the rate. I want to put some diagrams on the board. So everybody finish with the left-hand side of the board. I'm going to erase it. All right. So let's just use some diagrams to demonstrate it. All right. So you can understand a little better. All right, so let's start with competitive, right? I'm going to put two enzyme. So these are the enzyme. This is an inhibitor. This is an inhibitor. That's the substrate. So you realize that this part of each of them, right, can slot into the enzymes side. Now we only have one substrate here. We have two inhibitors. All of them have the same shape. So all three of them can bind. So these two inhibitors, so remember, this is an inhibitor. So for example, let us say the substrate here is maltose. We need maltose to be broken down. Without maltose, even protein, starch, right? All of those are substrate that needs to be broken down. If you have inhibitor present, that means your substrate will not be broken down. And that is what you need to happen. So if you have inhibitors, right, that are binding to your enzyme, good, your substrate will just be there. Nothing will happen to it. So the inhibitor is preventing your substrate from binding. So look, you need glucose, right, for cellular respiration. You have an inhibitor that is similar to maltase. Then starch will not be broken down. All right, so that is what inhibitors are preventing from happening. Now, because it is competitive, look what happens if we increase the amount of substrate. Let us increase the amount of substrate now. But the two inhibitors, you have 6 substrates, right, and 2 inhibitors. So what are the chances, do you think, that it is the inhibitor that is going to bind versus the substrate? Or which one do you think is more of a higher chance of binding to the enzyme? The substrate or the inhibitor?
They're the substrate.
Exactly right. So that is why for competitive inhibition, increasing the concentration of the substrate will remedy the presence of the inhibitor, because you're increasing the chances of the substrate binding to the enzyme instead of the inhibitor. All right. The next thing you should know, right? This reaction, right? It will still be going on, but it's just that it is slow. So remember, the inhibitor is not going to stay on the enzyme forever. It will come back off. When it comes off, then a substrate can bind. So it is happening slower. All right. And for that reason also, it is not changing your shape of the enzyme. All right. For competitive, the enzyme shape, it is not affect the shape of your enzyme. You can counteract it by increasing the concentration of the substrate. That's for competitive. For non-competitive now, which is allosteric, this is what happens. I don't have to draw a box for that. Let us say, right, let us say that this, hold on. I'll do it like this. Let us say that this is our enzyme. This part here, it is the allosteric site. Allosteric site. Remember the allosteric site, that is where the enzyme is going to bind. Sorry, this is where the inhibitor is going to bind. This is the active site. Let me try it again. When the inhibitor, I'm going to put the inhibitor in blue. Let us say this is our inhibitor. When it binds to the enzyme, it is going to cause the active site to change shape. So let us say the active site, it looks like this now. All right. So if this is your substrate, all right, when the inhibitor binds, do you think the substrate can still bind to the enzyme? What do you think? Inhibitor.
No, sir.
No, because the inhibitor has changed the shape of the active site. The question is, for this type of inhibition, would increasing the amount of the substrate change the rate? No, right, that is correct. Over here, inhibitor and substrate of the same shape, increasing the substrate will work. But you realize that in this one, the inhibitor changed the active site. All right? So that means it doesn't matter how much substrate is there. The fact of the matter is that the active site is no longer what it used to be. All right? So that is why it is non-competitive. Now, you have reversible and you have irreversible. All right? So reversible means that it is a temporary process where the substrate cannot bind. All right? So you have the one that is reversible and you have the one that is irreversible. So when some inhibitors bind to the enzyme, it is going to permanently change the shape. This one is the reversible one. So the inhibitor can come off, the active site goes back to what it was, and the substrate can bind. So this process is reversible. So let's make a note that this one is non-competitive, reversible. Let me just put it up here. So the enzyme shape, it's not permanently changed, all right? So that is why it is reversible. That means it can go back to what it was. All right, the inhibitor bind to the enzyme and change the shape of the active site. When the inhibitor leaves the inhibitor, it can come off. So we are looking at a process that is reversible. The inhibitor, it binds to the allosteric site, change the shape of the active site. So the substrate cannot bind to it. However, right, hold on. Let me put that back. Let me do a third one. So the inhibitor should leave now. You would get back the enzyme being with the same active site now. Remember, it is the binding of the inhibitor that changed the active site. So if the inhibitor leaves, the enzyme can get back its original configuration. That is why it is a reversible process. Is that clear for you?
Yes, sir.
And so after this, we're going to look at the the reversible one. All right, so let's go to the irreversible one now, where the active site will be completely changed. I'm going to clear the board, so if you haven't finished, just take a screenshot. All right, clear the screen. Right, by the way, the competitive, both of those were reversible. So we call them reversible inhibition. So both the competitive that I just showed you and the non-competitive one, those two were reversible because there was not a permanent change in the enzyme. This one here, the irreversible one, is when the change is permanent. So the enzyme cannot go back to what it was. All right. So when the change is permanent, that is when the inhibition is irreversible. So go ahead. Is the person that is there on? You have a question?
Yes, sir.
Go,
Sir,
yes.
so is it that reversible and irreversible inhibitions are types of the allosteric inhibition?
Right. So some of them. So for the competitive one, it is reversible, but for the allosteric one, it can be irreversible or reversible. This one, where it binds to the active site, forms the covalent bond and stays there. It is not going anywhere. That change is permanent. So once it's permanent, it's irreversible. Remember in the previous example, we said that the inhibitor can bind to a different site and come off. That one would be temporary, right? So that is why it is reversible. So the key word here is temporary and permanent. If the change is temporary, then it is reversible. If it is permanent, then it is irreversible. So two things. Inhibit. So it prevents the substrate from binding. That's what makes it an inhibitor. So whether it is competitive or non-competitive, right? Once it prevents the substrate from binding to the active site, that makes it an inhibitor. If it is not a permanent change, that is when we use the term reversible. In competitive inhibition, it is reversible because at some point in time, the inhibitor molecule will come off. It's not a permanent change. In the non-competitive one now, where the inhibitor binds to the allosteric site, and it will come back off, that part is reversible. But in this instance, where we say it is not coming off, or the change that is made is permanent, then that inhibition is irreversible. So once you have a permanent change in the enzyme, then it is irreversible. Is it any clearer?
Yes, sir.
All right, so the last thing I need to show you is end product inhibition. So that's a negative feedback mechanism. So if you remember from CSEC, when the digestion, when the blood sugar level is high, insulin is secreted to lower it. And when the blood sugar level is low, glucagon is secreted to try and bring it back to normal. This form of inhibition is something just like that, all right? So we call it end product inhibition. End product inhibition. So let us say, right, you have a substrate. Substrate A goes to substrate B, goes to substrate C. And enzyme X, so enzyme X converts A to B, and enzyme Y converts substrate. So A is substrate. All of them are substrate. Substrate, substrate. All right. What do we mean by end product inhibition? End product means the final product. So this is a sequence of events, right? You have A is converted to B, and then B is converted to C. So C is your end product. So we are looking at how the end product inhibits the overall process. So let us say this reaction, right? We want to produce C. You need a normal level of C, right? So 3 scenarios. 1, reaction progresses to produce normal levels of compound C. All right. What happens if C is in excess? If C is in excess, it prevents the conversion of A into B. It basically stops the entire reaction from taking place. It is basically inhibiting the reaction from taking place. So when C is in excess, A is not converted to B. So if A is not converted into B, then B is not being converted into C. So this reaction, it shuts off. All right, so A is not converted to B. B, therefore, is not made. So the production of C stops. All right, so get done? So if C is in excess, it stops the conversion of A into B. So it is basically inhibiting enzyme X. So that is what is happening. Enzyme X is inhibited. Enzyme X is inhibited. So again, end product inhibition. End product is the final compound in the reaction sequence. When the level of it is high, right, it is going to stop the conversion of A into B by inhibiting enzyme X. All right, high levels of your end product inhibits the reaction that starts the process. All right, so that is what end product inhibition is. All right, and so if this is not producing any, this one will also be out of play, because for this to be active, we need B to be produced. All right, so as a result, if there is no B, we would have no use for X. Right? All right, let me see here. I can explain it over. All right, so we are looking, so the term where it comes under inhibition, right? And the term is end product. So we are looking at how the product of a sequence of reactions inhibit the overall process. All right, so the reaction is A produce B, B produce C. This reaction is totally fine, right? But let us say for some reason, there's an excess of C. The body or the cell needs to stop the production of C. The high levels of C will inhibit enzyme X. So remember, the reaction starts going from A to B. The enzyme X converts A to B. Once A is converted into B, B is going to be converted into C. but the cell needs to stop the production of C. So what happens? Enzyme X is inhibited due to the high levels of C. The end product is C. High levels of C inhibits enzyme X. So that means enzyme X is not going to convert A into B. If A is not converted to B, B is not converted to C. And so no more C will be made. So the product C is literally preventing the enzyme X from working. It is inhibiting enzyme X. All right, so the term end product is because it is the final product. Inhibition, the final product, is inhibiting a particular enzyme. Is it any clearer?
Yes, sir.
All right. All right, so there's no here. I'm going to post a question in the community section. You can attempt it till we meet again. So when we meet again, we're going to do that question, look at cell structure, and some stuff from module 2. It will be sometime next week again, probably about Tuesday. But just look out for the notification in the community section, or maybe whoever sent you the link will send you again. All right. All right, so I'm going to end it here for today. The next chem session, well, I probably have to do one tomorrow. I'm not sure of the time as yet, but I will make a notice in the community section on the channel. All right, you are welcome. All right, thanks. Same to you. All right, so what else is there? Have a good day. All right.